All right, this is lesson 10, page 197, and we are modeling multi-step problems, okay? So Garrett is paid. Oh, this is a long story problem. So what is the first thing we're gonna do? We're gonna read all of it, okay? Garrett is paid $4 for each hour he babysits. Mrs. Becker pays him for 5 hours of babysitting. On the way home, Garrett spends $9 on a book and $6 on a puzzle. Write an equation to find how much money Garrett has left from the money Mrs. Becker pays him. So this is what we're asked to do. Write an equation to find out how much money Garrett has left from the money Mrs. Becker pays him. Okay? So we need to know how much he has left. So that means there's going to be some subtraction in there. So we need a total minus what he spent to equal how much he has left over. Okay. Well, where are we going to find that total? Garrett is paid $4 for each hour he babysits. Mrs. Becker pays him 5 hours of babysitting. That is my total. That's how much money he made. So total. How am I going to find that? $4 an hour for 5 hours. So we're going to multiply $4 an hour times the 5 hours. That's our total. Okay. On the way home, Garrett spends, which is our subtraction, $9 on a book and $6 on a puzzle. And that will equal what he has left over. Okay. So this is the equation, 4 times 5 to give us how much money he makes, minus the $9 for the book, minus the $6 for the puzzle, and that's going to equal whatever is left over. So this is the equation. Okay. You could also do total, how much he made, minus $9 for the book plus $6 for the puzzle, and that'll give us the same thing. Okay. These equations are the same. I'm going to solve both of them down here so that you can see why they are the same. Okay. So if I have 4 times 5, that is how much money he made, minus the 9 minus the 6 equals L. 4 times 5 is 20, minus 9 minus 6 equals L. 20 minus 9 is 11, minus 6 equals L. Oops. You notice how I get rid of it once I do it. So I figured out that, put my answer there, brought this stuff down. Did the next thing, because our order of operations tells us the next thing to do is to go this way. So 20 minus 9 equals 11. Bring down that 6 again. 11 minus 6 is 5 equals L. Now, if I was to do this equation, 4 times 5, because that's how much money he made babysitting, minus 9 plus 6, we'll get the same answer. We do parentheses first. 4 times 5 is 20, minus 9 plus 6 is 15 equals L. 20 minus 15 is 5 equals L. They give us the same answer. The difference is this took more steps because we had to subtract 9 and then subtract 6, or more subtraction steps anyway. These ones, we combine what he spent and then subtracted it from what he made. Both of these equations are correct. You could use either one of them. So Oh, he did this with a bar model. So Garrett is paid $4 an hour that he babysits, and he babysits for 5 hours. On the way home, Garrett spends 9 on the book and 6 on the puzzle. Write an equation. So you could use a bar model. So this is what he made. This is the total that I talked about. We said it was 5 times 4. Well, there's 1, 2, 3, 4, 5 hours times the $4. 4, 8, 12, 16, 20. This is what he spent. He spent $9 on the book, $6 on the puzzle, and then this in the green is what he has left over. So how are you going to find that? Well, you could have added these together and then subtracted from the total, or you could subtract them individually. Okay. Now it says, let B equal the amount Mrs. Becker pays Garrett. Okay, so 5 times 4, that's what we wrote up here too, 5 times 4. He spends $9 on a book and 6 on a puzzle. So we represent the amount he spends with the expression 9 plus 6 because we're combining the like terms. Okay, this is what he spent. So we can combine them and that's okay. So now we have G is the amount of, that's our L. So G is what he has left over equals B minus 9 plus 6. Do you remember what B was? B is the total, how much he made babysitting. So we're going to look at the second modelet that was represented by times 4 in the equation B equals 5 times 4. Oh, what is represented by times 4 in the equation B times 4? So times 4 is $4 per hour of babysitting. Okay. Why are the two amounts that Garrett spends in parentheses in the equation? They're in parentheses right here because you have to combine the like terms. These are the same. They represent the same thing. They represent money he spent. Okay. And they have to be in parentheses because you have to add them before you subtract it. You can't just put a plus sign there. So they're in parentheses because you have to add before you subtract. Alyssa combines the two equations into one equation. G equals 20 minus 9 plus 6. What does the 20 in her equation represent? Do you know? What does this 20 represent? It represents the money he earned babysitting. Ben uses the equation G equals 4 times 5 minus 9 minus 6. Is his equation correct? Explain. What did I say about this? Can you do this? You subtract? Yes. This equation is correct because you're still subtracting the money he spent. Remember, if I go too fast, just pause. So now we're going to explain how it is possible for two equations to look different but still represent the same problem. This is because different operations such as multiplication, division, addition, and subtraction, can be used to show the same amount. Okay. You can do number 6 if you want, but you don't have to. All right, let's try it. Number 7. There are 4 vans and 2 cars going to a museum. Each van carries 9 people, and each car carries 3. Write an equation to represent the number of people who travel in a van. Okay, this is our first step. Write an equation, people who travel in a van. 4 vans, van carries 9 people. Okay, we want it to be set equal to V. V equals 4 vans times 9 people. Okay. Multiplication is repeated addition, so you could have also done V equals 9 plus 9 plus 9 plus 9. And there's other ways you could have added it using the cumulative property. Okay. Then write an equation to represent the total number of people who got to go to the museum using T, total number for T. So T equals 4 times 9 plus the car. 2 cars, and each car carries 3 people. 2 cars, and each car carries 3 people. So that is our equation for that. Total equals 4 times 9 plus 2 times 3. Miguel has 28 markers. His sister has 33 markers. They buy 3 more boxes of markers. Each box has 8 markers. Write an equation to represent the total number of markers Miguel and his sister have. So I need to write an equation to represent the total number of markers. Miguel has 28. His sister has 33. Since we're dealing with total, we know we're going to add those guys. So 28 plus 33. They buy 3 more boxes, and each box has 8 markers. So because I'm buying boxes and each box has 8, that means we're going to multiply. Okay, so we're going to add those together because those are like. These are single markers. They're like terms, so we're going to add them together. Because we're finding total, we're going to also add the 3 boxes times the 8 markers per box. 3 times 8 equals total. Okay. So we have 28 markers plus the 33 markers that the kids have. And then they bought 3 boxes, and in each box there was 8 markers. And that is going to equal your total number of markers. This is when math gets pretty. Mrs. Barker buys tickets to the school play. She buys 2 adult tickets for $8 each and 3 child tickets for $5 each. She uses a coupon for $2 off the total amount. Write an equation to represent the total amount she spends. Write an equation to represent the total amount she spends. Show your work. So Mrs. Barker buys tickets to a school play. She buys 2 adult tickets for $8 each. So we're going to combine our like terms. So adults is 2 adults times 8 tickets each, plus 3 children tickets for $5 each, child. 3 tickets times the $5. But then she uses a coupon for minus $2 off. So minus 2 equals Total amount of tickets. So now you're going to do page 201 and 202 on your own, and be sure to fill it out in the Google form.